In this video, we're going to talk about Module 1, Topic 2, Lesson 4, and this is Part 4. So if you need to watch a previous part, go back and watch that first. So in this video, you should be able to answer the following essential questions. How does a minimum/maximum point of a quadratic function relate to the vertex of the quadratic function? If the y value of 2 points are 0, are the points x-intercepts or y-intercepts? Under what circumstances is it easier to write the quadratic function in factored form? Under what circumstances is it easier to write the quadratic function in vertex form? And how can an a value be determined when writing a quadratic function given the points of a quadratic function? And how do you know the concavity of the parabola? So, in previous lessons, you have used properties to write linear functions. Now we are going to use our properties to write quadratic functions. So as a reminder, we have 3 forms of quadratic functions. We have our standard form, our vertex form, and our factored form. Each form is good for its own thing. So typically standard form is our least favorite form, but it is useful when you do know the y-intercept because your y-intercept is C. Your vertex form is good when you know the vertex. So that is when vertex form is best to use. Factored form is best when you know your x-intercepts, your roots, your solutions, your zeros. So maybe we should make a note tying those words together that x-intercepts are also roots, zeros, and solutions. So all 4 of those words can be used interchangeably. Okay, so depending on the form, depending on what information we're given, determines what kind of equation we want to write and what is going to be quote unquote easiest. Now, one thing I want you to notice that all 3 forms have in common. All 3 forms have an a value. And the a value represents the same thing in every single form. It represents its concavity. So remember, when our a value is greater than 0, we have a function that is concave up. Remember, concave up is like a cup. So when it's concave up, you have a minimum. When our function or our a value is less than 0, our graph is concave down like a frown, which means you have a maximum. Okay, so let's get into writing some equations. So we want to write a quadratic function given the vertex being 5, 2 and the point 4, 9 being on our graph. So what we can do is follow these steps right here. So it says substitute the given values into the blank form of the function. Well, based on the key features we're given, we are given the vertex and we are given some random point. So when we are given the vertex, we want to substitute these values into the vertex form of the function. So I think it's helpful to write down the formulas. So vertex form, that would be y equals a times x minus h squared plus k. So what information we were given? We were given the vertex, which is our h and our k, and then we were given a random point. So the point is going to be our x and our y. And so what we need to do is we need to plug these values in so that we can solve for a. So we plug them in. Our y value is 9, so we're going to have 9 equals a times our x value is 4 minus our x value of our vertex, or h, which is 5, squared, and then plus 2 because we have a positive 2 for k. So now all we do is simplify and solve for a. So order of operations say we take care of grouping symbols first, which means we are going to subtract 4 minus 5. That is a -1. Next, order of operations says to take care of the parentheses. So we have a negative 1 squared, which is just a positive 1. And so now we can multiply. 1 times a is just a. So if you want to write this, you can, but you don't have to write this. We just have a plus 2. And now to solve for a, all we're going to do is subtract 2 from both sides. And we are going to get our a value. So 9 minus 2, which is 7, which equals a. So now we know our a value is 7. So then it says substitute the a value into the function with the vertex. So we're going to use this vertex form again, but this time all we're going to do is plug in for a, h, and k, and we have our function. So we have y equals 7 times x minus 5 squared plus 2. And this right here would be our final answer. This would be our equation that has a vertex of 5, 2, and specifically goes through the point 4, 9. Now, looking at this equation, since our a is positive, it's greater than 0, that means that our graph is concave up. Okay, since it's concave up, our vertex is actually the minimum value. Okay, again, we have a graph that is concave up. Our vertex is at 5, 2, which happens to be the minimum as well. Okay, so now looking back at our steps, just to put a number to them, this step right here was step number 1, where we substituted in the given values into vertex form, and then all of that was step number 2, where we solve for a, and then step number 3 is when we plug in a in our vertex to get our final equation. Okay, so looking at the next one, write a quadratic function given the roots -2, 0, and 4, 0, and the point 1, 6. So what I need you to know is that even if it didn't say roots, I need you to know that these 2 points are x-intercepts, our roots, our zeros, our solutions. So again, we need to tie in all the words that go with it. Okay. And another thing I need you to know is that when your y value is 0, then you have x-intercepts, zeros, roots, and solutions. So again, when your y value is 0, that's how you know you have one of those key features. Okay, so then we also have another random point that is 1, 6. So because this time we have our zeros, our roots, and our solutions, when we substitute these in, we want to substitute these in to the factored form. Okay, so when you plug them into the factored form, let's go ahead and write that equation. Again, the more you write it, the better that you end up remembering it. So we have y equals a times x minus r1 and x minus r2. So let's label our points. R1 and R2 are just our roots. So we know that R1 is going to be -2 and R2 is going to be 4. If you want to flip-flop R1 and R2, that's perfectly fine. Whatever came first was 1, whatever came second was 2. Then we have our point x comma y, and so all we're going to do is we're going to substitute that information in so we can solve for a. So what that leaves us with is 6 equals a times 1, because that's our x value. The minus sign is built in, and we are plugging in a -2. And then we have our x value again, so 1. And then this time we still have minus, but we are plugging in a 4. And now we just have to simplify to solve for a. So here we go. Order of operations says we need to clean up that inside because it is a mess. So first thing I want you to see is we have a double negative. And so in the math world, two negatives make a positive. Okay, over here we just still have 1 minus 4. So now we can simplify inside the parentheses. 1 plus 2 is 3. And 1 minus 4 is negative 3. Then we can multiply. 3 times negative 3 is negative 9. So that gives us a negative 9a. From here, all we want to do is solve for a. Since it's being multiplied, we are going to divide by negative 9. And so here, this is where we simplify the fraction. So 6 and negative 9 are both divisible by 3. So when I divide them both by 3, I get a negative 2/3. And so now we have solved for our a value. So from here, all we're going to do is plug back our information so we can get our final equation. So we have y equals our a value, which is a negative 2/3, times x minus, again, we're plugging in a negative 2, and x minus, we're plugging in a 4. And so we just need to clean this up just a tiny bit. So again, we have a negative 2/3. Once again, we have the double negative. So that would turn into x plus 2. And then here would just be x minus 4. And so this would be our final equation that would represent this quadratic function going through the roots negative 2, 0, and 4, 0, and also going through the point 1, 6. Now, when it comes to this step right here, if you can jump straight to this form, that's fine. But if you need to write it, write it. So going back to labeling our steps, this right here was step number 1 where we plugged in. All of that is step number 2, solving for a. And then this right here would be our step number 3. Okay, and now that I'm looking at it, we are substituted in with, that should say roots, but it should be fixed on your paper. Okay, so looking at number 3, I want you to pause and try A and B, and then come back and see how you do to check your answers. Okay, so this one I'm going to go a little bit quicker. So it says analyze the given points and determine which form of a quadratic function would be most efficient to write using the given information. So this one says that it's including a vertex and a random point. So when it's including the vertex, we're going to use vertex form. So vertex form is y equals a times x minus h squared plus k. So when you're given the vertex, you're given your h, you're given your k, and then your random point is x comma y. So you just plug it in. So we have 1 equals a times our x value, which is negative 4, minus, and we're plugging in a negative 3. It is super important that you be careful with that step. And then you have a plus 4. So now that we have it plugged in, we can go ahead and simplify. So let's start taking care of that inside piece first, because that's what is the most messy. So first off, right here, again, we have a double negative. So in the math world, a double negative turns into a positive. And then we can clean up that inside. So negative 4 plus 3 is a negative 1. Negative 1 squared is a positive 1. So that is a 1a. And then last but not least, to solve for a, we're going to subtract 4 from both sides. And so when we subtract 4 from both sides, we get a negative 3. equals A. And so that would be our equation that goes through the vertex of -3, 4 and has the point -4, 1. So let's go ahead and write our equation. So we have y equals -3 times x minus, and we're plugging in -3 squared plus 4. Go ahead and clean up the double negative on the inside. And again, if you can just do that without writing the first step, that's perfectly fine. But if you need to write it, please make sure you write it. So this right here would be our equation. So let's talk about a few things. What does this A represent? Well, our A is -3, which is less than 0. Since it's less than 0, we know that we have a quadratic function that is concave down. Since it's concave down, we know that our vertex is a maximum, and our vertex is -3, 4. So a maximum and the vertex are the same thing. Okay, the maximum value is just the y value of the vertex. Don't forget, we know that our axis of symmetry is -3. X equals -3. That's what would cut the graph in half. Okay, so again, just using the information we learned and putting it all together. So now, looking at part B, we want to write the quadratic function that includes the given points. So the given points are 2, 0, 8, 0, and then we have a third point that is 4, 6. So what I need you to know is that these y values are 0, so these x values are the x-intercepts. These are our roots, these are our solutions, these are our zeros. You have to recognize those points just based on how they're written. And again, the zeros are how we know. So because we have our x-intercepts, our roots, our zeros, our solutions, and a point, we are going to use the factored form. So the factored form is y equals a times x minus r1 times x minus r2. So let's figure out what points we're going to use. Let's let r1 be 2, and let's let r2 be 8. And if you don't like that, you can flip-flop them. That's perfectly fine. We have our x value and our y value. So let's go ahead and plug these in. So we have 6 equals a times 4 minus r1, which is 2. And then we have 4 minus r2, which is 8. And then we just go ahead and simplify. So here we go. Simplify the inside pieces first. 4 minus 2 is 2. -4 minus 8 is a -4. We can multiply. 2 times -4 is -8 times a is -8a. Go ahead and simplify by dividing both sides by -8. And this would give us a equals, and we do need to simplify this fraction. It would be divisible by 2 on top and bottom, so that would be a -3 over 4. And so this would represent our a value. From here, we just plug it back in to get our final equation. So we have y equals a -3/4 times x minus 2 times x minus 8. And that would be our final answer. That would give us the equation. So we have our step 1 right here. All of that is step 2. And this final one is step 3. So once again, based on our a value being negative, we know we have a concave down function. We do not know the vertex, but we could find it if we were asked. But what we do know is on a graph, it is going through the x-axis at 2 and 8. That is what we do know. Okay, so if you have any questions, please make sure you write this down and you ask in class.